Welcome all. So today's lecture is about deploying a .NET microservice to Kubernetes. And my name is Kaushik Chowdhury, and I have made the first part as introduction in this previous episode, which is now here in the description of this YouTube. And now I have decided to cover the rest of the tutorial in one flowing tutorial, which will cover this following chapters, following parts. What are orchestrators? And there is exercise push a microservice image to Docker Hub, and an exercise to deploy a microservice container to Kubernetes, another exercise to scale a container instance in Kubernetes, and another exercise to prove microservice resilience in Kubernetes, and then conclusion. And as in the first part, which was a standalone part, was of introduction with this case study on the Contoso pizza store, it was derived on the Microsoft documentation based on the Microsoft article and the code also. So this is the link, docs.microsoft.com and US learn modules.net deploy microservices Kubernetes. And I thought that it is a better idea to make everything in one single course so that it will give you a smooth and streamlined experience, so that you don't need to go from one lecture to another and wait for the next lecture. Okay, so let's jump over to what are orchestrators. So as introduction to orchestrators to the containers are like conductors to an orchestra. Now, at least some of you, I hope, have visited an orchestra or a symphony orchestra or a concert where there is a conductor and a band of players who play different musical instruments like guitar, piano, violin, and many other things. And they are under a harmonious direction of a conductor who is the leader, who actually leads the orchestra with his hand and movement of sticks, so that this entire team of orchestra functions as a smooth team, which actually creates a unique user experience in terms of music. So orchestrators in computer science, in IT, they achieve the following functions: to scale out apps, respond to increased demands by deploying more container instances, scale down if the demand decreases. And these activities need deploying, monitoring, updating, and removal of containers that introduce challenges in complex solutions. Now, coming to container management, it is the process of organizing, adding, removing, or updating many containers. And continuing about this fictitious Contoso Pizza Company website, which we introduced in the first lecture about the introduction, and it consists of several microservices responsible for tasks like caching, data processing, and shopping cart, to just name a few. And this is the Microsoft image, which shows that there are three services that we have already discussed: caching and data processing and a shopping cart. Say these three microservices are representing those three services that I've just told. And each of the above services is hosted in a container that can be deployed. Now this is the shell. Let's assume for a second that this is the container that is hosting these three microservices. And that container can be deployed, updated, and scaled independently of these services can be deployed, updated, and scaled independently of each other. And if, say, the shopping cart service needs to scale by increasing the number of containers, it will need to deploy a new version. You'll need to update every instance of that container. And a container orchestrator is finally a system that automatically deploys and manages containerized apps. So as an example, the orchestrator can dynamically respond to environment changes to increase or decrease the deployed instances of the managed app. And it can ensure all deployed container instances get updated if a new version of a service is released. Now in this following image, it shows that dynamically this orchestrator dynamically adjusts the number of container instances, and it automatically updates the running instances. So now some of the benefits of using Kubernetes are based on abstraction of tasks like self-healing, dynamic scaling, and rolling updates. Now what's self-healing? Self-healing of containers. As an example, it would be like restarting containers that fail or replacing containers, and scaling deployed container count up or down dynamically based on demand. Also automatically rolling updates and rollback of containers, and then managing storage, managing network traffic, and storing and managing sensitive information such as username and passwords. Because Kubernetes is a tool to orchestrate containerized workloads, and you can deploy .NET microservices into containers. You can use Kubernetes to orchestrate your .NET microservices, and that's what the rest of this module will teach you. In this part, we'll do an exercise. It's a practical hands-on exercise, so I think you'll get it quite interesting. Okay, so we'll push a microservice image to Docker Hub. So here it how it goes. What is a Docker Hub? Now for Kubernetes to create a container image, it needs a source for the image. Docker Hub is this image source or source for this image, which provides a central place to upload the Docker images, and Kubernetes can create containers based on images in Docker Hub. Now there are some prerequisites for this exercise, which is you have to have the Docker desktop application downloaded and installed, and Docker Hub account, and a text editor like Visual Studio Code. So you can download the Docker desktop from this www.docker.com products Docker desktop, and for following the directions to sign up for a Docker Hub account, you have to log into hub.docker.com. You have to create a registration and sign up to the Docker Hub account from this. Now, first thing we'll do is to get the Contoso Pizza Shop microservice code from GitHub. So we'll clone the repository from this GitHub source code repository for Microsoft, github.com/Microsoft docs/mslearn.net Kubernetes. Accordingly, we will do it on Visual Studio Code. I will open an instance of Visual Studio Code. So I have opened the Visual Studio Code, and this is the terminal, and I have browsed to a newly created folder within my Dropbox, which is I am using extensively so that it is available from anywhere I would like to work, anywhere in the world. Okay, so it's on the cloud. So anyway, and this is I have created this folder microservices with Kubernetes. Now let me clone from the Microsoft GitHub source by issuing this command, which I am on clipboard, and then click on enter, and it is cloning this GitHub code into mslearn.net Kubernetes. Okay, so just in a second it would have done all the code download. So now if we wish to have a look, it's already there. The code is already downloaded from the GitHub source code. All right, now what we'll do is we'll now verify the Docker images by creating the containers locally. So we have done this part, cloning the repository from GitHub to retrieve the code, and then there are actually two containers in the Contoso Pizza Shop project, and let's use them to create the containers locally before pushing the images back to the Docker Hub. Okay, so once the containers are created and running, we shall be able to browse the Contoso Pizza Company website in a sec. So by that means, after we are able to create the containers and we browse to the Contoso Pizza Company, we can verify that microservices are running. So don't worry, we'll do everything one by one, step by step. Just please bear with me and view this course from end to end to get the best value out of it. Okay. Now, to create and run Docker containers, we'll have to confirm that Docker desktop is running. Okay, so this bullet point writes to the presentation that for it to create and run Docker containers from the Docker files we downloaded, confirm that Docker desktop is running. So where are the Docker files? So this is one of the Docker files that we have downloaded from the source code, and that is the front end. And if you wish to browse the backend folder, you'll find that another Docker file is there. So Docker file is basically containing all the instructions to create a Docker to build a Docker container from a Docker image that we have actually got from the Docker Hub. Okay, so Docker file contains all those instructions. We'll come to that later. Now we'll have to confirm first that the Docker desktop is running. In my case, it is running. I can show you in a sec. So you can see that this is my Docker engine. It is running, and I've also logged into Docker Hub with my username and password, and which I have already created earlier, krcom6645. So if you don't have any Docker Hub account, we'll come to that in a second, and you can register free of cost for a website that I will give you shortly. So now you have to open, first of all, you have to get the Docker desktop running, which you would have already downloaded and installed from a previous slide that I have shown you. And I assume that you have got a command prompt and change the directory to mslearn.net Kubernetes, like I have done in my Visual Studio Code. And then the third thing is you have to run this command, docker compose build, to build the containers. So I now paste this instruction, docker compose build, this command, and I hit enter. So no configuration file provided, not found. All right, so I'll have to browse to what the mistake I was doing was. I'll have to bring it to the front end. So this command in microservices with Kubernetes folder, it is mslearn.net Kubernetes. So basically I will copy it from here, this folder name, copy, and then because it was not the correct folder name, that's why it protested, it did not create. So I cleared the screen, and then I cd to this directory, mslearn.net Kubernetes. That is where the YAML file is, because if you look at this physical directory, mslearn.net Kubernetes, where this docker compose.yml file is there. So now if I give the same command, ms build docker compose build command, so if I give this command, it should be all right now. This time it is building. Okay, so it is building the containers, and it will take some time to build the containers. And first time, and if you run it the second time, this will take much less time because many of the instructions will be cached. So I will come back after this containers are created with the docker compose build command. We can see it is still building. It takes a wee while because it has to follow lots of instructions, Now finally it has taken a wee while, and it has been able to build the containers. Now we'll have to give another command, which is docker compose up. Now this up command will run the app, and it will attach the containers. Okay, it is still attaching to mslearn.net Kubernetes. All right, we'll come back again after the operation is finished. Now we have finished till step 4. We have done the docker compose up, and these containers are now running. So let us browse to this location, this URL, localhost port 5902. Here you go. Here. Aha, so all the containers are running and they are now attached to the pizza shop with the local host on this port 5902. So pizza name, ingredient, cost and in stock. Right, so first part is successful. Now all we have to do, what we have done, we have actually got to the Docker Hub. We have withdrawn, we have actually downloaded the images, relevant images, we have created the containers and we have run the containers, and we have browsed to the site that is being contained within the container at this port 5902, and everything is fine so far. Now next we will sign into the Docker Hub account. Okay, so the next step in uploading the image is to sign to the Docker Hub account with the same credential that you used when creating the Docker account. So, and if the password needs to be reset, if you have forgotten the password and it needs to be reset, then you can visit this URL https://hub.docker.com. Okay, and then for uploading the images that we have created locally, and you have to retag or rename those Docker images that you have created under your Docker username, because now we have pulled it from the Docker Hub, okay, and then created run our local containers, and then we'll push the images back under our own username and password, and then push to the Docker Hub. So it will be under our own credentials. Okay. So this is one of the first commands, that's docker tag pizza frontend. So your Docker username /pizza frontend, and docker tag pizza backend, your Docker username. So this user Docker username, in my case it is krcom6645, which is again, so this is my Docker Hub account with my username being krcom6645. See, I already have some Docker repositories. Okay, and now let's go back to the Visual Studio Code. So the application is still running, so I will make Control-C to end the application. Gracefully stopping, you can see, press Control-C to force. Okay, so it is already now, the application is now closed. Okay, so now if so clear screen and reissue this, rather than using the clipboard instructions, let me type it, which saves time and does it the correct way. So docker tag pizza frontend. So, and next was your Docker username. So my Docker username is krc home 6645 /pizza frontend. Okay, so docker tag pizza frontend krcom6645 /pizza frontend. That will be the retagged renaming of the image that I have created. Okay, now I'll have to do it for the back end. So instead of front end, all I have to do is to type the correct thing, pizza backend. Okay, so pizza backend, also change the front end to back end here. I think most of you prefer to rewrite everything pizza backend. Okay, so docker tag pizza backend krcom6645, my username /pizza backend. Okay, so hit enter. So it would have already tagged it. Okay, on my local. Then finally I would upload or push the Docker images, because these are Docker images, back to the Docker Hub. So that is the What is the command? If you have guessed docker push, you have guessed it correctly. So this is docker push. Docker push, again my Docker username, 6645 / pizza frontend, so docker push krc home 6645 / pizza frontend. Okay, and then using default tag, see this is all preparing to push it to the Docker Hub again. After retagging, it's taking a wee bit of time. We'll come back again and issue the other command to push the backend image also to the Docker Hub. See, it is still pushing. Now this push, you can say, this push refers to repository docker.io / krcom 6645 / pizza frontend. So it's still under pushing. So we'll come back after it has pushed, and then we'll push the final image to pizza backend. Okay, and I will verify that it's all there. See now, krc home 6645 pizza frontend. So it's already there. Last pushed a minute ago. Okay, so now let's go back to our Visual Studio Code and push the backend image. So now I will do docker push. So docker push krc home 6645 / pizza backend. Okay, and then hit enter, and it will, using default tag latest, the one that we have already given in the previous commands. So docker tag command. Okay, so we'll come back after it has pushed, and I'll show you the latest images for the backend. So now it has pushed, it has been able to push the front end image as well as the back end image. So let us go to that, this refresh with the browser. So you can see it is krc home 6645 pizza backend. All right, we have learned in this. So we have cloned the Contoso pizza shop code from GitHub and created 2 Docker images and containers by using Docker files contained within the source code, and pushed or uploaded those images back to the Docker Hub. Thanks for watching. Hello everyone. So in this part, this is another exercise to deploy a microservice container to Kubernetes. So how does Kubernetes works? Kubernetes runs the containers for the users, and users describe what they want Kubernetes to do through a YAML file, YAML file. We'll shortly see what an YAML file looks like and its various functions of its various stages. So this exercise will walk you through the creation of the YAML file so the users can deploy and run the backend service on Kubernetes. And we shall be using the Kubernetes implementation included with the Docker desktop. So how do we ensure that Kubernetes is running? So on my Docker desktop, which is this, and my Docker engine is running, which I've already shown you, and just click on the settings and click on Kubernetes, and you have enable Kubernetes and version 122.5. Okay, so all I need to do is to enable, tick this checkbox. Okay, and it will be enabled. So it starts a Kubernetes single node cluster when starting Docker desktop. Right, so let's get back to our issues. So first of all, we'll be deploying create a deployment file for the backend service. We have seen a backend service is there and a front end service. So we have run the containers in the earlier part. Okay, So now these are the next steps in the deployment process. Create a deployment file for the backend service. So we'll start with that. So we'll get back to switch over to our Visual Studio Code. This is my Visual Studio Code, and I have browsed to the microservices with Kubernetes, where I cloned the repository, Microsoft repository, in my previous part. Okay, so in the Visual Studio and in the directory, root directory, where I cloned this code, which is this one. Okay, I will create a new file and I will call this. Okay, let's create a new file first. New file, and I will give it a name. Backend deploy.yml. Alright, so that's created for me. Now I will paste this code, and I will, for the sake of time, I will paste this code and will then explain. I'll just file save this file and close it. So this is the YAML file, backend deploy.yml file. So let's go through this. Now here, use your Docker username. So I will have to replace this with my username, which was krc home. .6.6.4.5 pizza backend. So wherever this was, so there's only one place that I needed to change my name, and click on Control C to save the file. So this is the image, and container port is 80. These are the environment variables, and this is the cluster IP service. So now let's see, the first portion defines a deployment spec for the container. So this is the deployment spec for the container that will be deployed into Kubernetes. It specifies there will be one replica. So there is replicas 1. Where to find the container image from? The container image will be found from this, my username on Docker Hub, krc-home6645/pizza backend latest. That is the latest tagged, so which we have already pushed into the Docker Hub in my previous part. All right. So as I told, it sets some environment variables, and the first portion also defines labels and names that the container and specs can be referenced by. So name pizza backend, and there is a labels which is within labels app pizza backend. Okay, and now second portion, this is the cluster IP part. It will run as a Kubernetes cluster IP. For this module, you don't need to understand all of the specifics of the cluster IPs, but do know that this type of service does not expose an external IP address, and it is only accessible from other services running from within the same Kubernetes cluster. That's how it works. So it doesn't have any external, it doesn't expose an external IP address. So you cannot just browse with external IP address, like even localhost : port, some port or something. So it's accessible from other services running within the same Kubernetes cluster. Okay, now we'll deploy and run the backend service. So what we'll do, we'll open the command prompt. So there is a control and backtick, hotkey control and backtick. It will open the terminal straight away, and I will run this command. Here you can see I created, let's see, directory check. So directory listing. So this is a directory listing, and let's see. So this is the root directory, microservices with Kubernetes, and I'll change the directory to list the contents of mslearn -.NET-Kubernetes. So change directory to mslearn -.NET is the spelling all right? mslearn -.NET -Kubernetes. All right, now here if I do the directory listing, it will have this file backend deploy.yaml. all right, now on this terminal window, which is now with the which is actually browsed to the mslearn.NET Kubernetes where I developed this file backend deploy.yaml, I'll run this command. So this is kubectl apply is a switch f backend deploy.yaml. So kubectl apply f backend deploy.yaml. all right, so what this command is doing, this is telling Kubernetes to run the file we just created. Okay, so deployment.apps/pizza backend created and a service /pizza backend created. So these two are created already. So by clicking, so this is actually running the Kubernetes application. Kubernetes to run the file we just created. It will download the image from the Docker Hub and create the container. Now next is this apply command will return quickly, but the container creation may take a while. So to see the progress of the container creation, we give this command kubectl get pods. Okay, already running. So this is pizza backend, it's ready, 1 out of 1 running. Restart 0, each 50 seconds only. Right, so it's already running. So you can see this pizza backend, okay, in the resulting output. It is following by string of random numbers, random characters under the name column. Okay, and this is the name column, is a string of random numbers after pizza backend. Okay, when everything is ready, there will be 1 by 1 under the ready column, which is what it is. Okay, now if I browse to this directory, this URL, so let's browse to a directory. /localhost/ pizza info. It will bring a 404 error, 404 not found. This error is because the pizza backend service is not accessible from the outside world. That's what I told you earlier. Okay, because it is not available from outside. Right, so we have done this part, create a deployment file for the backend service, and also we have to deploy and run the backend service. Okay, now we'll create a deployment file for the front end service in a similar manner. So let me alt tab to this, and I'll create another file, backend front end deploy.yaml. So there is a new file, front end deploy.yml, front end #deploy.yml. It's all created for me. So I will paste it for the sake of brevity and saving a lot of time typing. So this is the code for the backend. Save it. It's similar to the backend. This is the code for the front end, sorry, and it looks very similar to the backend code except some changes which I will explain to you. Now here also I will change it to my Docker username, which is again, it will be different for you, all of you. It will be totally different depending upon what you used as your username for pushing the Docker Hub, images to the Docker Hub. Okay. Now here what we are doing, that there are some difference between the backend microservice and the front end microservice, this YAML. We are specifying a different container to run under the deployment spec.template.spec.containers.image. So this is KRC home 6645 / pizza front end, and that was pizza backend. Okay. Right. And what the next difference is, there is a new environment variable under this spec containers environment name. Okay. A spec template, spec containers, and then environment. So you see the hierarchy like this. So this is very important that these indenting is maintained properly. So under spec, this is template, and then under template is spec again, and then under spec is containers. These are child elements of the root element is this, again root element of spec is this, root element of template is spec. So environment. So the code in the pizza front end application calls the backend. Okay. So it is actually name http://pizza backend. Okay, but because we haven't specified a fully qualified domain name, nor we will know the IP address of the backend microservice, we use the name we specified under the metadata.name node of the deployment. Okay, so we use the name specified under the metadata.name. So pizza front end, that is the thing. Okay, and under the deployment, so under deployment metadata name pizza front end, so we'll be using that. Okay, Kubernetes will then take care of the rest. And in the service section, we are specifying a load balancer. Okay, for spec.type type under the spec load balancer, and port 80 is open for that. This means that we'll be able to browse the pizza front end by navigating to http://localhost. Okay, so in the backend deploy there's nothing like this mentioned. It was only port 80, but there's no spec type load balancer. All right, here it is. It was cluster IP, and it is load balancer. That is the difference. So cluster IP means within that IP, within that Kubernetes cluster, so it will be visible from one service to the other, from okay, within the services, but not to the outside world. But here we can view it from http: browsing to http://localhost. Okay, and then I will deploy with the apply command like we did for the backend. So let me get this by control and backtick terminal again. Okay, and right, so kubectl apply. F so if there's no typo, it should run kubectl apply f frontend deploy.yml. Right, great. So deployment.apps slash pizza frontend created and service slash frontend created. Okay, so it apply returns the result quickly, but container is not created so quickly, so we can get the pods, it will get pods. So you got it. Okay, it's already running one by one, and pizza backend running and then ready one by one, and pizza frontend also ready. So now if we browse to localhost, then we should have both the microservices running. Let's see. I'll bring the browser. Okay, open a new window. http :// it is port, it is default, so http / localhost. Okay, now somehow the localhost, the default port, that is 80, is not configured to show you the front end, pizza front end. So what I did finally, after some trial and error, I changed the container port to 8000, which is a free port I knew, and other than the default port 80, I made the container port to 8000. Okay, and then also the load balancer port to 8000, and here also the environment variable, it is actually 8000 on the container. All right, so after that, when I browse to localhost port 8000, it showed me the this front end, which is what we wanted actually. So if you refresh it, it will still working. So what I did is that I had to reconfigure the front end service. So control backtick to bring the terminal. Okay, so kubectl apply this flag F, it is forcing it to happen. So apply F stands for file name, So apply this configuration, which is in this file name, frontend deploy.yaml. Okay, this will do, it is applying the frontend .yaml. It is running the container, it is creating the container, running it, and it is, so you can see that deployment .apps slash pizza frontend configured and service slash pizza frontend unchanged. Okay, so after that, when I browse to this localhost 8000, it's some pizza, the menu. Okay, so in this exercise, we created a deployment file that described exactly how we wanted the containers to run within Kubernetes. Then we had Kubernetes download the image from Docker Hub and start up the containers. In this part, which is also an exercise, we'll scale a container instance in Kubernetes. So how does Kubernetes scale up? Microservices may come under heavy load during certain times of the day, and Kubernetes makes it easy to scale our microservices by adding additional instances for us. And these are some of the commands to scale up and down. To scale the backend microservice to 5 instances, so we issue this command, kubectl scale -- replicas equals 5 deployment / pizza backend. Okay, so we'll do that practically. We'll just clear the screen and start once again. Deployment / pizza backend. So kubectl scale -- replicas equals 5 deployment / pizza backend. Okay, so let's see. Okay, so it has scale. It says deployment.apps / pizza backend scale. So the reason we need to specify deployment / pizza backend instead of just pizza backend is because we are scaling the entire Kubernetes deployment of the pizza backend service, and that will scale the instances of the individual pods correctly. So in order to verify the 5 instances are up and running, so what is the command? kubectl get pods. All right, so you have got 1, 2, 3, 4, 5 pods running. Okay, 5 instances running. Right, now if you wish to scale it down, just make the replicas equals 1, and then of course verify with kubectl get pods. So just delete it, equals 1. Okay, so it's scaled and kubectl get pods. Now you've got just 1 backend. So previously it was 5 backend pods, So now that's all for this lecture. So we have seen in this lecture how to scale up the instance and scale it down as the demand or load to the microservice gets increased. Okay, and in the next lecture we'll prove the microservice resilience in Kubernetes. Hello everyone. In this part, which is pretty much the last part, this is another exercise, final, to prove microservice resilience in Kubernetes. So main advantages of Kubernetes is that it is the support for declarative configuration management. As we have seen, the YAML file that we have created for front end, deploy and back end, that is actually being followed ditto by Kubernetes. And the services defined in the configuration files will be retained at all costs, no matter what. That means if there is a failure, the Kubernetes will automatically restart services that were running before the failure. Now let's see this resilience in action by deleting the pizza front end pod and then verifying that Kubernetes has restarted it. So what I will do, I'll just clear the screen, CLS command, and then I will use this command, kubectl, again kubectl get pods. So pizza backend and pizza front end. Now I will now delete the pizza front end pod by using kubectl delete pod. Delete pod and then gap. This time should be all right. So delete it. Okay. Now you run this kubectl get pods. Now you can see the front end pod is different from the one that we deleted. So that was 545 db7 fb87. It is still this part, and the last part is changed, b846m. Now it has changed to zwst6. Okay, so we see that this random string followed by the pizza front end name has changed, indicating the pod is a new instance. Also this age value is only 6 seconds as opposed to 16 hours earlier, so that says that it is this pod is a new instance. Okay, so in this exercise you learned how Kubernetes will automatically maintain declared system state even if there is a failure. Now that we have finished our course, let's summarize and conclude from what we have learned so far. So, hosting microservices in their own containers is a common pattern for microservice-based development. A container orchestrator is a system that automatically deploys and manages containerized apps. So, Kubernetes is the container orchestrator platform that we have worked with in this tutorial, which is a portable, extensible, open source platform for managing and orchestrating containerized workloads. And what have we learned in this course? So to recollect, we have learned how to take a .NET application that was already partitioned into containerized microservices and deploy it into Kubernetes environment, and push the Docker images to Docker Hub to make the images available to Kubernetes instance to download, and created deployment files to declaratively describe what Kubernetes should do to each microservice, and how easy it is to scale a microservice using Kubernetes, and prove the resilience of microservice in Kubernetes. Thank you for watching.